Hello students, this is Karthik, your maths tutor, heartily welcoming you all to Vista's Learning. What is Vista's Learning? Vista's Learning is an online education platform where we strive to deliver quality education for all. So we'll be continuing from the point where we left in the previous session. Alright? So in the previous session we started with class 11 second chapter, that is relations and functions, and we saw what is a relation. And we have also defined what is a relation with the help of Cartesian product. So just let us have a very quick recap of whatever we saw previously. We'll be starting with the new topic today. Alright. So the recap, what we saw in the previous class. Okay, we saw about Cartesian product. Okay. And we also saw what is the meaning of relation. So how is relations? What is relation, students? Relation is nothing but a set of ordered pairs, and this is also the subset of this Cartesian product. Alright, so this is what we saw in the previous class, Cartesian product. So what is Cartesian product again? It is a multiplication or the product between two non-empty sets A and B, okay, which are represented in the form of A comma B. Okay, the ordered pairs such that A belongs to set A and B belongs to set B. Okay, so this is how the Cartesian product is defined. So this was the recap. So going on to the next topic. So we saw what is Cartesian product first. Then we saw what is relation. How is relation defined, subset of Cartesian product. The next topic for today's class is functions. Okay. So let us understand what is functions. Understanding what is function. So we know what is relation, right? So what is relation, students will write here. Relation is nothing but subset of Cartesian product. Okay, and relation is also defined as a set of ordered pairs. So today what we are going to see is the next topic, that is nothing but called as function. So what is a function, students? Function is a relation only. Okay, so what is function? Function is a relation. Function is also a relation. But what is special? What is special with the function? So it is a special kind of relation. Okay, function is nothing but it is a relation only, but it is a special relation, that's all. Function is a special relation. So what is the speciality about the function? Okay, the speciality about the function is, for example, in relations, the ordered pairs are given like this: 1, 1, 1, 2, 1, 3, and it goes on like that. So here if you see, the x values or the first elements of this ordered pairs are same, correct? And the second elements are changing. So here it is 1, here it is 2, and here it is 3. Okay, so this will not occur in function. Very simple. Okay. So we'll be seeing the definition of function. Right now we'll be only understanding what is function. Okay. So we'll go further. So function, you can understand it something like this, students. So we'll have a box here. Okay, this box is nothing but function. So that is nothing but f of x. So let us define what is f of x. F of x can be anything. So here let us take f of x is equal to x square plus 4. Okay, so this is f of x. And where is this f of x? This f of x is inside this box. Okay, so from here what we'll be doing, okay, we will be inputting the values of x. And from here we'll be getting an output, right? So that is called as values of y. So how is the ordered pair represented again? X comma y. So this is how the ordered pair is represented. So now let us put the values of x one by one. So let us put x is equal to 1. Okay, x is equal to 2. X is equal to 3. And we can go on so far. Okay, we can go on putting the values of x. In this example, let us only take 3 values of x. Now, when x is equal to 1, so in the place of x, you put 1 square plus 4, correct? So you will be getting how much, students? 5. Similarly, you put x is equal to 2, that will become 2 square plus 4, so this will become equal to 8. And you put x is equal to 3, that will become 3 square plus 4, okay, you will be getting 13. So now how can we represent functions? Relations only there, but special kind. So how do we represent functions from here? So here we can write, it is 1, 5, correct? 1, 5. Similarly 2, 8, and 3 comma 13. Understood? So these are functions. So these are relations only, but it is a special kind of relation. What is special, students? The first element, so each and every element of X will be having only one image in Y. Understood? So this is called as a function. So what are these X elements called as? Domain. And what are these Y elements called as? Codomain. The range is the lowest and the highest value in the codomain. So this is called as functions. Moving on to the next one, we'll see the definition of function, what is given in NCERT. Same thing, whatever we have discussed in this slide. Okay, so function is nothing but a special kind of relation. The first, only one image will be available for each and every element of X. So just remember this. So the same thing, students, okay, we'll be seeing here. So functions, so these are the definitions of functions. So see this one, first one. A relation F. So what was F, students? In the previous example, what did we take F as? So we took F as f of x, that is nothing but function of x, is equal to x square plus 1. So this is what the example we took in the previous slide. Okay, a relation F from a set A to set B. So set A was what? So here set A was 1, 2 and 3, correct? The x values. To set B. And what was set B, students? Set B was 5, 8 and 13. This is what we got, correct? A relation F from set A to set B is said to be a function if every element of set A has one and only one image in set B. Means, so when you map the students, it will be something like this: 1, 2, 3. So here it is function F. Okay, and here we'll be getting what? The codomain or the range. So that is nothing but 5, 8, 13. Now just map the students. Okay, now if you see this here, for 1 you will be getting 5, for 2 you will be getting 8, for 3 you will be getting 13. So is this getting satisfied, you see? Is said to be a function if every element of set A, so this is set A, okay, this is set B. Every element of set A has one and only one image in set B. Understood? So this is called as a function. So what is not a function then again? So for example, if we had, same example we'll take 1, 2, 3. So here we'll take A and B. So these both are also numbers only, alright. So I'm just not writing the numbers. So how the numbers are presented here, in the very similar manner, there are numbers here as well. But we are taking the help of variables only. Okay. So if suppose 1 equals A and 1 equals B, if it is happening like this, okay, then it is not called as a function. But see this another one. If suppose here we have 1, 2, 3 and here we have A, that's all. Only A here. 1 is tending towards A, okay, 2 is also equal to A, 3 is also equal to A. This is called as a function. Understand, students? If the same element X or 1 in the codomain, in the domain has two images in Y, okay, then it is not called as a function. But each and every element in X has the same image in Y, okay, that will be called as a function. So this is a function. This is not a function. This is also a function. Understood? So that is what this definition is telling. A relation F from set A to set B is said to be a function if every element of set A has one and only one image. So mark this, one and only one image in B. So see that it is satisfying here. It is not satisfying here, but it is satisfying here as well as it is satisfying here. So this is called as what? A function. I hope it is clear. Okay, if not, please do comment in the comment sections. Okay, I'll be retaking this, okay, in a very simpler manner. Okay. Moving on to the next one. So same thing only, in other words, a function F is a relation from a non-empty set A, correct? Non-empty set A. See the checkout A here, it is non-empty, to a non-empty set B, such that the domain of F is A. Domain of this function, what is the domain of this function? That is A, and no two distinct order, okay, domain of the function of F is A and no two distinct order pairs in F have the same first element. Same thing. So These both are the distinct elements, right? They should not have the same element in X. So in other words, that's all. Both are same. In other words, they're telling. Okay, moving on to the next one. So if f is a function from a to b, a comma b belongs to f, then f of a is equal to b. Means, same thing students. So previously what we saw in the previous example, f of x is equal to x square plus 4, correct? And what did set A have? Set A had 1, 2 and 3. Now let us take this element. So f of 1, correct? So capital set A, and these elements are called as what? These elements are A1, A2, A3. So A is belonging to set A, like that. Okay, so f of 1 will be equal to 1 square plus 4, so that will be equal to 5. So f of A is equal to B, correct? So see here, f of A is equal to B is equal to 5. So f of A is equal to B, where B is called the image of A under the function and is called the pre-image of B under F. Means, so what we got here, if you put in the place of X, what is the value we are inputting? We are inputting 1, correct? So this 1 is called as what? This 1 is called as pre-image. Pre-image of what, students? Pre-image of 5, correct? 1 is called as the pre-image of 5, whereas what is 5 called as? 5 is called as image of 1. Okay, so that is what is written in the third definition. So I have explained all the three definitions here, 1, 2 and 3. Okay, so pre-image, image of 5 of 1. Okay, so this is called as a function. So students, the point to be noted down here is the very first definition, okay, the green color, whatever I highlighted that. Apart from this, understand this example, understand this example, and understand this example. So these three things, or 4 things we can take. So this is number 1 you take, okay. So this will be number 2, number 3 this box, and number 4 this box. So these 4 things, okay, just remember them. It's very simple. So this is called as a function. So we'll just solve a couple of examples of problems related to this function. So whatever we have done in today's session, okay, we'll just do a couple of problems and see what are the outcomes. Okay, moving on to the next one. So a function, how is the function defined again? A function f from a to b is denoted by f is to a to b. Okay, so for example, now see this. So one small example we have taken. Let n be the set of natural numbers. So what is n? So we already know that it is a set of natural numbers starting from 1. And the relation R is defined on n such that R is equal to xy. What is this xy, students? Ordered pairs, such that y is equal to 2x. See the function here. Y is also equal to what, students? Remember, y is also equal to f of x. So now what is f of x? F of x is nothing but equal to 2x. And what is x, students? X is nothing but set of natural numbers. So natural numbers we'll write here. N equals 1, 2, 3 and so on. Close the set. Okay, so y is equal to 2x such that x comma y belong to set of natural numbers. So see this, x comma y belong to set of natural numbers. So the question here is, what is the domain, codomain and the range of R? What is R here again? R is nothing but this relation R. Okay, is this relation a function? So there are two questions here. You have to find out what is domain, codomain and range. That is number 1. And the number 2 is this relation a function? You have to tell whether this relation is a function or not. Okay, we'll solve this problem now. Okay, on the left hand side. So f of x is equal to 2x, students. And what is x? X is nothing but domain. So that is nothing but set of natural numbers. So let us put 1, 2, 3, 4. So f of 1 is equal to 2 into 1, which is equal to 2. F of 2, which is equal to 2 into 2, which is equal to 4. F of 3, which is equal to 2 into 3, which is equal to 6. Correct? So what are the functions? So what are the relations we can draw from here? 1 comma 2, 2 comma 4, 3 comma 6. So map them also. 1, 2, 3. So here you will be getting 2, 4, 6. Okay. So again, one element in X has only one image in Y. One element in X has one image in Y. One element in X has one image in Y. So one element has only one and only one image in Y. So what is this? Is this a function? Yes, this is a function. It is a function. Now, going back to the very first question again, what is domain? Domain means what? Input values. So what is domain, students? Domain is nothing but set of natural numbers. What is codomain? Codomain is also nothing but CD will write. Okay, codomain is also set of natural numbers. But what is range? Range is set of even natural numbers. Correct? So see the codomain, see the range here, we are getting even numbers only, right? 2, 4, 6. Irrespective of you are inputting an odd number or an even number, okay, the output is always even only. So the range is set of even natural numbers. Codomain is natural numbers, and so this will also be a set of even natural numbers. And domain only will be set of natural numbers. So the very first example of functions. Alright, moving on to the next example. So the second example. So this will be the last example for today's class. Alright. So here we have got the second example. Examine each of the following relations. So see what is given here. Relations is given. We have to examine these relations given below and state in each case giving reasons whether it is a function or not. So there are three relations given, 1, 2 and 3. So we have to look at them and tell whether this relation is a function or not. So to answer this question, students, okay, you have to be very thorough with this slide. Okay, so remember this. Number 1, the definition of function. Okay. Number 2, this. Have a look at this. Okay. Have a look at this and have a look at this. With the help of these 3 plus the definition 4, okay, we can easily answer the second example. All right. So just make a look. Have a look at this. So we'll go back to the example there again. Okay. So now see the students. 2, 3, 4. We'll write them here. 2, 3, 4. And on this side, what we'll be writing? We'll be writing only 1 and 2. 1, 2. Now start mapping them, students. So if you start mapping them, so 2 is 1. For 3 also we are getting the output as 1. And 4 we are getting the output as 2. So is this a function? So I think this is very similar to this one, right? See this? 1 is A, 2 is A, 3 is also A, but here it is B. So 3 is B. So this is what we have got in the second example. Is this a function? So I have put a tick mark here. Yes, it is a function. So you have to only understand this. It has only one and one element, one and only one image in set Y. So 2 is having only one image, 3 is also having one image. So this is a function. See the next one, students. We'll try to map them as well. So number 2. So 2, 4, 3, 4. Okay, 2, 2, 3, 4. So 2, 3, 4. Okay, and here what do we have? 2, 4, 3, 4. 2, 4, 3, 4. 4 is there again. Now map them, students. Map this second one. So for 2 what we have? 2 only. For again 2 what do we have? We have 4. Correct? For 3 we have 3 and for 4 we have 4. Okay. Now see this. This element of X has 2 different images in Y. 2 different elements of X has only one image in Y. This is a function. Understand? 2 different images in X, 2 different pre-images in X has only one image in Y. This is a function. Same pre-image in X has 2 different images in Y. This is not a function. So again in that slide, 4 points I told you to note down, right? The same thing is happening here. Okay, nothing different. Moving on to the next one, number 3. 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6 and 7. So we'll map them as well. So it will be something like this. So this is number 3, students. So in the set of x, 1, 2, 3, 4, 5, 6 we have. And in x we have 2, 3, 4, 5, 6 and 7. So try to map them, students. So when you map, you will be getting something like this. For 1 we have 2, 2 we have 3, 3 we have 4, 4 we have 5, 5 we have 6 and 6 we have 7. So each and every element in x has only one and only one element or image in y. So this is again a function. Got it? So make a note of this. Same input, okay, same input, x is 2, is having two different outputs, 2 and 4. It is not a function. See here, two different inputs is having the same output. It is a function. So just be clarified with this as well as this. If you get these both things, so that is it for functions. So we'll be stopping the class here. So in the next class there is only one more topic which is left out in relations and functions. So that is graphs on the functions. So different types of graphs and different types of functions we'll be seeing. So that will be the last topic, students, in the second chapter of class 11. I'll be seeing you in the next session with the last topic. Until then, please subscribe Vista's Learning, like the video and kindly share it. Thank you, students.